In this session, we're going to talk about understanding the science of surface water. And of course, as we've all heard the last day and a half, science drives water policy. That's a joke. Not really. Maybe not at all.
That's a good one.
There are certainly a lot of moving parts when you talk about solving water issues and setting water policy. But I think still it's a whole lot easier when you have sound underlying science that supports what you're trying to do and is defensible. So with that, we're going to hear today from three experts in really three kind of different fields of surface water science, each of which is certainly relevant to solving water problems, addressing water issues, and water policy. Dr. Bill Espey is our first speaker. He's currently the Director of Water Resources for LJA Engineering. Bill's been in practice, engineering practice, consulting practice for a long time, and I have to say, Bill, I was thinking today, you and I have known each other for 50 years. Yes. Beginning in 1968.
When you were working with Dr. Frank Mash, one of my godfathers.
We were sharing a cubicle, I think, up in the attic of Taylor Hall at University of Texas. So
yes, sir. We
go back a long way. But Bill has a long, distinguished career in water resources type work. He served on a number of important committees, like the Lake Michigan Water Diversion Committee. He's been chairman of that technical committee for a number of years. He's also been involved on the expert panel for the Mississippi River Diversion and Implementation Project that's sponsored by the Water Institute of the Gulf. Bill's going to provide an overview of surface water resources and talk about water planning in the state, both in the past and present. Our next speaker is Dr. Larry McKinney. Dr. McKinney is currently Executive Director of the Harte Institute for Gulf of Mexico Studies at Texas A&M University in Corpus Christi. Dr. McKinney formerly was with Texas Parks and Wildlife. He was instrumental in a number of environmental and aquatic resource programs for that agency and worked there for a number of years. He also played an important role in developing language for Senate Bills 1, 2, and 3, which all address various aspects of environmental flows. He's going to discuss kind of the evolution of environmental flow requirements in Texas as we know them today. He's going to talk about what we're doing today and probably about what we should be doing. Finally, Dr. Wurbs is a professor here at Texas A&M in the Zachry Department of Civil Engineering. Dr. Wurbs has already been acknowledged as the father of a computer program called WRAP, Water Rights Analysis Package, and this is the computer program that's utilized now throughout the state of Texas for water availability modeling. And you've heard about water availability modeling this morning, and Dr. Wurbs was the originator of that program in some 25 more years ago and is still actively involved in that program, working with the state. And it's been my pleasure to work with Dr. Wurbs since we really started water availability modeling back in the mid-90s. So with that introduction, I'm going to ask Bill Espey to lead off with his presentation.
Thank you, Bob. I'd like to share with you some of my thoughts, and some of them are rather historical that I have to share with you as I prepared for this meeting. I started looking back in my library at different documents, and I came across this first one, which is the legendary vagaries of Texas water, more amusing in folklore than actual experience, discourages any hope of relief through improvement in its natural behavior. If Texans cannot change the weather, they can at least, through sound, far-sighting planning, conserve and develop water resources to supply their needs. This was in the 61 water plan. And the next one, this is in 1967. It was here at Texas A&M. It had this introductory statement. Let me turn the page. The conference began during those dry days that continued after the rain came, because it is our firm conviction that there is no resource in Texas more important than water. I am firmly convinced that the most important factor in the solution of the nation's water problem is to give proper recognition to the importance of water resources development and management. In the 1967 Water Conference at this campus, who made that statement, that introductory remarks? General Rudder. Earl Rudder. Incredible. The next slide shows the agenda of some of the people that were here. Water leaders across this state. Trig Twitchell, godfather of water quality agencies. USGS. Hugh Yanis, godfather of water quality. And if you look down at the bottom of this first column, and I don't remember this, I was here. It goes to show you, 67, I was here. And I started reading this document. Don't laugh too loud, now come on. Some of this I've heard before. If anything is not common and occurs all the time, it's the weather conditions and droughts and floods. And we talk about weather change. It changed yesterday, I believed it. I know I'm exaggerating. What I'd like to show you briefly in the limited time I have are some slides of background information pertinent to the complexity of this subject. This, of course, is our state and our water systems, our reservoirs, approximately 188 over 5,000 acre feet. Here's the variation in precipitation, tremendous variation in precipitation. This graph is a little hard to read, so the board put it in this format, where you see the 55 inches across the state to 10 and 15, etc. Dramatic change in picture. You heard earlier someone talking about the availability in water systems in East Texas. You know why? It rains a lot in East Texas, or more. Surface evaporation, obviously that is an important factor. And I remember a number of years, and maybe Bob, you were more involved in this, but some initiatives were going on with LCRA to put something into the surface water to protect and reduce evaporation. And I think it was coming out of somebody on the East Coast to reduce the evaporation on the lake in some way, control it. It was not very successful, but this is a possible subject for future technology. Here's proposed population growth, and you can see this. I'm not telling you anything new here. The Dallas-Fort Worth area, the Central Texas, San Antonio, Austin, and the Houston area. And you can see some in the Valley area there of growth. Tremendous projections. If I remember my numbers, about 70% growth plus between 2020 and 2070. That was mentioned earlier. Here are the municipal water needs that follow those high population areas that is projected in the water planning. Here's the stream gauging network. Earlier in my career, I was very involved with the USGS in these various systems, making measurements out here on the Brazos, the cable car system, making flow measurements of the Brazos. Here are the river authorities, which in many respects are an essential element and heart of some of this water planning, and frankly, implementation of it in many respects, and guidance. There's more and more complicated issues that have grown in the last few years. We were talking earlier about the environmental flow issues and the evolution of that. I happen to be the BBES chair for the Trinity San Jacinto Galveston Bay. It was so controversial that the BBES recommended to the stakeholders 2 sets of criteria. We couldn't agree. And then the stakeholders couldn't agree, and they submitted 2 to TCEQ. The 2 factions in terms of trying to rationalize and evolve on some of the environmental flow issues, a very challenging subject. And then TCEQ promulgated the criteria and came more in a balanced context of one of those recommendations that we submitted. That is still going on as we speak today. We have some members, I believe, from TCEQ here, as well as the Water Development Board, in leading the continued appropriation and study of studies to look and update that criteria. And it is challenging with a tremendous talent. A&M is very involved. Dr. Quigg in the estuary part of the study, tremendous work that they've been doing over the years. Here are the regional planning areas, and we've talked about those a little bit as we've gone through. Let me jump ahead here myself. These are the regional planning areas, which is the heart of the planning work that is done, the guide in the development of a state water plan. We already mentioned this, but again, somewhat in summary, the late 50s drought is the period that got everybody's attention. It is still the drought of record that we use as kind of a guide. We've heard some other issues related to other areas that have other controlling drought periods, like 2011, I believe I heard someone talk about their area. And you see that this is the backbone to some degree of the water planning, WRAP modeling. You remember, some of you may remember the Burley Ditch to move water out of the Mississippi into Texas. Anybody remember any of that? I got a hand over here. One of the things I remember, and again, this was kind of early in my career, someone said it would have been cheaper to move everybody from West Texas to the Mississippi than move the water to West Texas. Now, I don't know how true that was, but anyways, it didn't work. And then we got into Senate Bill 1 in 1997, related to the development of a bottom-up regional planning approach to meet our water needs. These are the 16 regional planning areas. The emphasis was, to some degree, to go back to the basics in those areas, bottom up, so to speak. Prepare then the state water plan by the Water Development Board based on those regional plans. The 2017 that I'm going to talk a little bit more about is the 10th plan since 1957 and the 4th since the 1997 Senate Bill 1 revisions. So again, these regional planning efforts reflect these interests. These are the category interests that by legislation they're supposed to reflect. And I believe there are 12, if I remember correctly. Municipal, groundwater management use, river authorities, etc., water districts. So they're the heart of a lot of this work. Your regional planning has existing water supplies, projected water demands, and then surplus or needs. This is over the 50-year planning horizon. And here are the existing reservoirs. Like I said earlier, is 188 scattered around the state. Many of you obviously are familiar with some of these. And this is a recent picture of the conservation storage in our reservoir system. during the drought that the reservoirs existed at that time, et cetera, et cetera. And it shows, the latest number I have is the whole system, this is for the state now, is 85% full on the conservation storage. So it gives you can see some of the recent drought periods in 2010 approximately. You can see that drop. And here is what is recommended in the new water planning. Just lost it here. You heard some of these discussed in the north part. Allen's Creek, you might have heard about on the Brazos. There's discussions with the city of Houston. Ralph Hall, Bois d'Arc, am I saying that correctly? Bodark, excuse me. Bodark, to name a few. Reservoirs in various stages. LCRA has some on the Colorado. These reservoirs have become more and more challenging, in part because good, shall we say, the better sites are limited. The sites, in short, are getting more scarce. Plus, the regulatory environment has become more and more challenging, and the costs for these facilities are more and more challenging. So these three elements have combined to make some of this permitting a challenge. Some of you are probably familiar with Marvin Nichols, a big reservoir in East Texas, very controversial as well, to some degree because of, I would humbly suggest, local perspective in that area versus, shall we say, the Dallas-Fort Worth area. And the perspective of that need being fulfilled by water from another area. I mentioned Allen's Creek. Some of you see there on the lower parts of the basins on the coast. Some of these are so-called off-channel reservoirs. Some of them actually are on tributary creeks, which still requires a permit, but they're not on the main channel. Here's the population I mentioned earlier, as well as some other people, of the tremendous growth in millions projected to 2070. 70% plus that growth is going to occur. So that inherently is going to challenge our water needs. Here's the demand and the existing supplies. Again, for the total system I'm looking at here, surface and groundwater. Bob suggested I move a little quicker. I'll try. I've tried to summarize for your consideration how they're going to meet that in a summary, with reuse being in the neighborhood of 13–12%. Conservation, a big factor for the future, 26%. Desal, 3%. New reservoirs, you could see that in 2070, it gets up to about 13%. Other surface water has to do with existing supplies, the possible reallocation of that, getting the pipelines and pump stations to move that water to the areas that are needed. The size of that number somewhat surprised me. And in summary, these are the opportunities. Funding financially, obviously, is a very key issue. Technology, fundamental to that is desal and alternative strategies, water efficiency and conservation, continued support for the core coordination required with permitting and regulatory issues. You heard Kevin Ward talk about this regulatory climate in terms of NEPA and the imbalance in that between federal and non-federal projects. That is another major, major issue in the regulatory context. And what else last I got here? Engagement in the process. Here's this cooperative letter that was signed in 2016 of the cooperation with the Water Development Board and EPA in a regulatory context, which is a positive step, but it needs to go further because it starts raining, apathy sets in, concern, it gets drowned in a flood, and then panic starts, and we're in the same cycle again. Am I on time?
You did fine.
Thank you for your attention and questions.
Thank you. I think we'll just keep moving along, and Larry, you start your presentation.
All right. And I appreciate it, Bob. As an old-time lecturer, I'm a lot more comfortable standing up and walking around talking, but I'm going to try to sit right here. And also, I'm a firm believer in the tactical advantage of a moving target versus being a sitting duck. Particularly since I'm the only biologist in these 2 days of meetings that are on a panel amongst some engineers, which I appreciate, attorneys, whatever, but that's fine. But like my it's an order of things. Like my great uncle Hugh was a Texas Ranger. What was described to them? He said, "Well, it's one riot, one Ranger." So I think that's how it's going to work out for us. So I'm going to try to do this quickly. First, the obligatory commercial from the Research Institute. We operate in 3 principles. One is that we think that traditional academic-based models are failing to meet the needs that we're addressing, a lot of what we're addressing right here today. And we do believe in science-driven solutions to problems. We also recognize that people are part of the environment and they need to be part of the solutions. And we do think also that you can have a healthy environment, a healthy economy that go hand in hand, and we try to work at it that way. And we're organized in that direction so that around a group of chairs. I would note that we do have, for example, a chair in marine policy and law, an attorney there, and a socioeconomics chair, economics, both of which report to a biologist, their boss, me. So that's pretty unusual for anyone working for a biologist, but that's how our institute kind of comes at things. One of our big issues and that we're going to focus on is environmental water and how we incorporate that into water planning and development management. I appreciate Commissioner Baker's plug earlier on about kind of what we're aiming at, and we'll talk about that a bit. We do have some resources there. Myself, as we talked about, I've been in this business, but more importantly, our economist, David Yaskowitz, and Paul Montagna, many of you who know, is probably the most preeminent scientist in freshwater inflows studies anywhere in the world, frankly. So we're happy to have those two working here. We're about to establish over the next year the Mitch Mathis program in environmental water economics in cooperation with all those groups that you see on the stage. We're very excited about bringing that together. And that program will be launching actually in the next several weeks and hopefully going forward into the future. So let's launch into the basic science of it. Freshwater inflows, they actually by definition create these estuaries because they do 3 things. One, that they create these salinity gradients in which all these animals in the estuaries at some stage of their life, from eggs to juvenile to larvae, juvenile, subadults, they live in different salinities and need that. That's what estuaries are. These freshwater inflows bring nutrients into these systems. They're one of 3 sources. You have solar power coming in and generating food. You have plant debris and detritus on the banks, creating debris, and that they live on that, but also these nutrients that come in from the rivers help create these systems. And then finally, the sediments, because our bays are always continually compacting and getting deeper. These new sediments come in. Many of the plants that live around the margins depend on certain depths, and of course certain flooding regimes are important. So all of these things create estuaries. Now that's what we think of it from a science aspect. From another perspective, it's basically this, that these healthy estuaries support a valuable fishery for us here in Texas, and multiple billions of dollars, something like $6 billion worth of economic impact. Around the Gulf, it's over $16 billion because the Gulf of Mexico is defined by these estuaries, so that's a tremendous benefit. Also for tourism, and it's a big industry in the Gulf of Mexico, but the one issue that's more important to all of us here in this room that we all depend upon, that we don't think about much, are these ecosystem services, which basically these healthy estuaries, functioning estuaries, act as a tertiary treatment for all the wastewater that we empty into them from the cities that live on their margins and the rivers that come down them. If they weren't functioning, basically all that in blue on your slide would be just basically one big sewage pit. A treatment pit. And so the value of our real estate around there, our health and our well-being depends on these healthy functioning estuaries. We know what happens, and also before we get this one last point, that the Texas estuaries from a scientific standpoint are a wonderful laboratory, because many people have talked about this gradient of inflows that we have, a very high inflows starting at Sabine, basically no inflows in the Laguna Madre, but that whole range gives you, it's difficult from a management perspective on a statewide basis, but from a scientific perspective and looking at solutions, if you can find solutions here, it has applications all around the world. Bill talked about the drought of the 50s as a defining moment. It certainly was for the issue of environmental flows, because during the drought of the 50s, at that time, of course, we made the decision we don't want to go through that again and launch one of the largest reservoir building programs probably anywhere, with now over 5,000 square miles of surface water, more surface water than the state of Minnesota, the land of 10,000 lakes. So it was all that effort never to go through the drought of the 50s again. But it had environmental impacts, and it came at a cost. Basically, with some of the things, we've lost about half of our natural heritage here in Texas. Now, we're a big state, and it's a wonderfully dynamic state, but as our population grew, we burned up about half of that natural resource. And as we talked about, the population is going to continue to grow and double or so. Are we going to burn up the rest of the state? I don't think so. I think that's a balancing issue that we're going to have to deal with, and water is central to that issue of how we maintain what really defines Texas and where we want to live. That's the crux of the issue that we're going to be dealing with. We know that other places in the world, they've failed to do that, and the examples are abundant of where that's happened and what we need to do to try to address it. So we have plenty of examples of what can happen if we don't reach that balance, and of course that's a big part of our challenge. So now kind of turning to the history of environmental water in the state. Much of this has been discussed, which I appreciate. I'm going to pick out two of the really important ones, because really Texas is a world leader in addressing the issues of how to look at environmental water over time. Countries from around the world come and look at what we've done to set up the policy structure and how we address it. Now, whether we're making use of it, that's the debatable question. But there are some important ones. I'm just going to pick out two to talk about. One, 1985 House Bill 2, and then, as Bill summarized very well, 2007 Senate Bill 3, a couple of aspects on that. First, House Bill 2, that was really a species management approach where the legislature said, let's look at the economically and recreationally important species. Let's see what it takes to maintain the economic impact that they have. And as a result, our resource agencies, that's where I became first associated with Parks and Wildlife, and that was one of my charges, is to help do this. And so we took a look at the redfish, the spotted sea trout, crabs, shrimp, oysters, those types of things, and tried to look at what water it would take to assure their continued health and productivity. And so this was the result of a lot of work, primarily between the Water Development Board and a great friend of mine, and who's now passed, but Gary Powell, who helped lead this work and put this together. And as we put these numbers out on the table as to what it would take to maintain the health of these estuaries, you can imagine the response we got when we talk about millions of acre feet of water that needs to come into these estuaries. It was an interesting time and launched quite a period of time. At the time, I was of course, with Parks and Wildlife, and my chairman, Joseph Fitzsimmons, after I was in his office complaining about getting beat up so much, because basically, as you know, what happens, if you can't fight the science, first you try to create something else, and then you make personal attacks. So it got pretty nasty for a while there, but as Joe Fitzsimmons said, Larry says, it's not your science that they're giving you hell about, it's they just don't like the answers. And so that's what we were having to deal with. So as I was putting this presentation together, I went back into my files 15 years ago, PowerPoints are still there, and pulled out the next series of slides to kind of characterize that era of time since we put those proposals together in 1900. So this was, at the title of my slide was the fact that I heard several times, and some recently, is that a drop of water past my dam is a drop of water wasted. And we saw the evidence of that sometime, because there's sometimes at points you could stand on top of the Rio Grande River. We did that more than once. That's one of them there, me standing on top of the mouth of the Rio Grande River. But that was an attitude that we began to deal with. Now, it began to shift slowly over the mid-'80s, where the next kind of thought was, well, we built this lake for people, not fish. If they need water, they can pay for it like the rest of us. So, and actually we're coming to the point where we may be talking about doing that type of thing. But that was the attitude. Now, it changed. It says, I'm an environmentalist, but, and I'm going to tell you that's one of the heaviest buts you can ever have in this, because basically it meant that I'm an environmentalist as long as it doesn't cost me anything. That's really kind of what it translated as, but that was beginning to change. But then you begin to really see some change in thoughts about, okay, we really got to figure this out, and you begin to see things like we have to strike a balance between humans and the environment, and begin to think about how we actually move forward over that time in the late 90s. But then came the San Marcos River Foundation, the Smurf case, where it was this was a kind of a very much of a turning point on a lot of this issue, where this foundation followed all the rules, happened to be in the right place at the right time, with a revision of your famous models to something. All of a sudden, a lot of water became available that no one knew was there, supposedly, and this environmental group was first in line, ready to go and get it. That was an effort that never delivered a drop of water to the bay, because the legislature came in and shut all that down and put an end to it, making the point over all this time that two things. One, attempting to secure environmental flows and quantities. I'm talking about millions of acre feet of water to support these species. It really failed in those times. It wasn't going to happen, and it really became clear from an environmental perspective this state was never going to allow for an environmental-based permit for the quantities of water they were talking about here. Then came Senate Bill 3, and I thank Kevin for his very cogent summary, and others that talked about where we were on the water quality standards. So I don't have to repeat where we went through on that. Those standards came into place over a period of time from 2011 to 14. In contact with TCEQ, there's been about 50 permits where this standards have been applied over that time. The question is, have they been effective or not? And we really don't know that. But how do we evaluate that part? And this is a project that I started a few years ago with the beginning of the Deepwater Horizon oil spill. The idea of, can we even talk about the health of the Gulf of Mexico in some kind of objective approach? And so we're about, in fact, probably the next few weeks, we'll release our prototype of how we would do the entire Gulf of Mexico. We use Texas as a model. And as several speakers have said, when you look at the health of our estuaries and the coast using fisheries and shellfish, oysters, seagrass, and in this case birds, we are in a pretty good shape. Our bays are relatively healthy. Now there's some issues, for example, with oysters, but that has to do with the hurricane impacts and sediment coverage and not so much water quality issues. I had water quality as one of the factors we put in this report card, but we pulled it back out, in that we had some evaluation that talked about as much as 50% of our estuaries were impaired in some way, as opposed to some numbers that said 30 or 40. And we want to be really careful in this report card that everything that we lay out in it, we brought the best experts that there are together to evaluate this, and based on a lot of really good data. But the data from the water quality side was not what we wanted. It wouldn't support either way. So we pulled it back and reevaluate that to make sure that we're on good standings, whatever we say. So we're not there. But water quality is clearly an early indicator and important for what we're talking about. So all of this brought about, after the summary of things, for 30 years of our experience, we've come up at HRI as Commissioner Baker put a pretty heavy load on me a few minutes ago about this idea of focus flows and looking at different approaches to come at this business. That's what I want to wrap up on. What we talk about in focus flows is the way to create these natural hatcheries or refuges at the heads of bays during drought periods. And if we can establish those, what our preliminary data shows, for example, in the Corpus area, that when you're in a drought and you recover from a drought, that recovery could take 4 or 5 years more for the system to come back to full function. But if we deliver the water in the right place at the right time, we can, in fact, speed that recovery up, and that has a tremendous value. And as we said, the system, our bays, we think are quite healthy now. The issue is where we want to look at droughts. Focus flows don't really address this bigger issue of ecosystem health and productivity, but they do give us something we can look at in dealing with water. The economic value can be calculated. I want to move a little more quickly to time. I want to get to a couple of points here just to show the point that we can calculate the economic value of these focus flows in recovery time. And what we're talking about here, of course, are flows. We're talking about tens of thousands of acre feet, perhaps not millions of acre feet. That water is available in many of our systems. There are many things that are going on these days, like aquifer recovery and off-channel reservoirs can make a significant mechanism to help deliver these types or these quantities of flows. Market approaches can be used to purchase waters in these quantities, and most importantly, I think the politics of securing focus flows is a way to come at this issue to deal with a very important period of time, the one area that has not been addressed by standards in dealing with droughts. So these are things I think that we can do to come forward with looking at how we can deal with the full range of environmental issues, perhaps not quite so combative as they've been historically. It would be, all of us would appreciate it. Some of us are getting older, not all of us. But we reach that point where we recognize you got to balance all these things, and that's really there's that balance we need, and so that would be my summary.
Thank you, Larry. That was good. Okay, we want to hear from Dr. Wurbs and bring us up to date on water availability modeling.
Well, when we normally, I think, when we think about large, complex simulation modeling systems and methodologies for statistical reliability frequency analysis, we think about science and engineering, and WAM is science and engineering. However, you will note my subtitle, Institutional Dimensions of Computer Modeling. So the point there is, I want to emphasize, along with the science and engineering, the modeling system incorporates institutional aspects of water management, as will become evident as we progress here. Terminology, the Water Rights Analysis Package, WRAP is a generalized modeling system that can be applied any place. It's actually been applied by researchers and practitioners in a number of different countries. However, none of the other applications have been anything like the extent of the applications in the state of Texas. The WAM system consists of the generalized WRAP system designed for application to river basins any place, plus input data sets for all the river basins of Texas. So the 15 major river basins and 8 coastal basins are modeled as 20 different WAMs, and we use the term WAM also to mean if you take the WRAP modeling system with an input data set from the TCEQ WAM system for a particular river basin, that's a WAM for that river basin. I mentioned the subtitle, Institutional Dimensions, and I've listed 2 very different institutional dimensions. One thing WRAP certainly, and the WAM system certainly, is modeling hydrology and constructed facilities, infrastructure, reservoirs, and so forth, but it's also modeling a water rights permit system with 6,200 water right permits based upon their prior appropriation system, which we discussed earlier this morning. Interstate compacts, 5 interstate compacts, treaties between the U.S. and Mexico, other contractual arrangements with these institutional aspects of water management are combined with the science and the constructed facilities in the modeling system. And then from a totally different perspective, the development of the modeling system is a partnership effort of an entire water management community. TCEQ is lead agency, but has done a fantastic job of working with the entire water management community in implementing the WAM system. Now, if you look at the published literature, it's absolutely massive. The literature dealing with a river reservoir system analysis, computer models, thousands, literally many thousands of papers. Most of those papers have never seen practical application. They've been products of university research that never saw practical application. So what's different about the WAM and the WRAP? That's on the board here. The WRAP WAM system is implemented by an entire water management community, and therefore it's actually utilized. We've gone through the milestones in Texas water management history. the implementation of a permit system pursuant to the Adjudication Act. Took 25 years to do that, but then Senate Bill 1 recognized, the Texas legislature working with the agencies recognized that if we've got a permit system and we need to be able to understand how much water we're managing to effectively manage that water. And we've talked about the regional statewide planning process that came out of Senate Bill 1. And then since then, a major focus when we talk about the WAM system is to continue to improve the incorporation of the environmental flow standards into the WAM system. The water rights system, I've already said, it's a generalized, WRAP's a generalized modeling system that can be applied any place. The monthly version of the WAM has the monthly data sets, and those those WAMs have been routinely used for 15 years now. We're 15 years into that. But motivated largely by the Senate Bill 3 environmental flow standards, we're developing under the auspices of the TCEQ here at Texas A&M, we're continuing to work on the daily modeling system to be able to incorporate environmental flow standards. And there's conventional long-term planning studies. That's the main application. You can also do, has been mentioned earlier, short-term. Here we are today. What are we going to be able to do over the next irrigation season, over the next period of time? We call that conditional reliability modeling. And then another major issue is continually updating the data sets, being able to continually, TCEQ continually adds water rights permits to the water rights data set, but then the hydrology, as we live longer and longer, we accumulate more and more hydrology to be updated. The Texas WAM system, 3,400 reservoirs and the 20 data sets. There are many, many reservoirs in the state of Texas, most of the storage capacities and a relatively few large ones. Bill mentioned about 188. I've said about 200 with conservation storage capacities with more than 5,000 acre feet. That's most, that's 90-something% of the total storage capacity in 3,400 reservoirs. And then there's 7 of those that have more than a million acre feet. And then there's conveyance facilities, other constructed facilities. We've mentioned there's over 6,000 water right permits. There are 5 interstate compacts, treaties between U.S. and Mexico, Corps of Engineers contracts for storage, and Corps reservoirs contract with non-federal sponsors, other types of agreements. All of this is modeled in the WAM system, along with the hydrology, as well as constructed facilities shown here. Applications, the TCEQ maintains the system and uses it in the preparation, evaluation, of water right permit applications. The applicants or the consulting firms working for the applicants use the modeling system in the permit application process. TCEQ staff uses the modeling system to evaluate the permit applications. The WAM system provides information related to the reliabilities at which the proposed water use can be supplied. And then it also evaluates impacts, if any, on the reliabilities of all the other water users in the river system. And then the modeling system used in the Senate Bill 1 regional statewide planning process, and then river authorities, other water management entities use the modeling system for their own operational planning studies. And Larry mentioned the uniqueness of the state of Texas, and I think we probably all realize that Texas is a model for water management, I think, internationally and throughout the U.S. And I've told groups outside Texas this many times. And here's and one of the contributions of this modeling system is consistency, that the regulatory agency, the planning agency, the planning studies, the permit applications are using the same modeling system, which then encourages the operational planning studies by river authorities and so forth to use the same modeling system. Everything's related. If you do a planning study and from that planning study you implement a water management strategy, you're going to have to get a water right permit to implement that strategy. If you're using the same modeling system in your planning studies as you're using your permitting process, it makes for I think, more effective water management. The WRAPMAM user community, you can read the list here. The TCEQ worked closely with its partners agencies in implementing the modeling system, and then the agencies continue to use the modeling system. The consulting engineering firms provide a lot of the technical support to the permit applicants, the regional planning groups, and so forth, in applying the modeling system. In my view, the TCEQ has done a fantastic job of collaborating, working with the water management community. I think since 2006, I believe there's been 11 WRAP user group conferences with 30 to 40 to 50 people from the river authorities, the consulting firms, and all meeting together to discuss the modeling system. And I think in addition to the technical aspects of modeling, it helps to have all these people together in the same room. The regulatory agency, the people submitting permits, the planning people, all together occasionally is another contribution of the modeling system. Bob Brandis is the chair of the WRAP subcommittee of the Surface Water Committee of the Texas Water Conservation Association. And they're not bashful about providing written suggestions to Kathy Alexander and the TCEQ about what can be done to improve WRAP, to make it better. And that's an integral part of the continuing evolution of the modeling system. We're all familiar and have talked about the diversity in the state of Texas, hydrologically, climatically, geographically, population density, and so forth. We divide the state into the 50 major river basins, 8 coastal basins, and that provides the basis to developing the WAMs. And so here's a listing of the 20 WAMs, 3,435 reservoirs, and all of them look like the Trinity has the largest number with 703. Brazos has 670. There's 10,530 water rights in the WAMs, according to this slide. Now, we said that there's about 6,200 permits, so what that means is model water rights, some of the more complicated permits, we have several model water rights to model one permit. But those are the WAMs. The WAMs basically combine historical hydrology with a specified scenario of water resources development and management. We're all interested in the next 50 years, not the past 50 years, but none of us have lived the next 50 years, so we use historical hydrology adjusted to represent natural conditions as a representation of, at least statistically, the statistical characteristics of what can be expected in the next 50 years or the next 100 years. So we're combining adjusted historical hydrology representing natural river basin hydrology with a specified water management and use scenario. All the reservoirs, we've constructed a lot of dams, so they exist today. And then one example of a water management scenario, the TCEQ uses authorized use scenario. The basic premise is, what if everyone used all the water they're legally entitled to? Another scenario that's used is the current use scenario. We may not be currently using all the water we're entitled to in all of the permits, so what if we were just using the amount of water we're currently using? And there are other scenarios. So you combine water resources development management, regulation, allocation with historical adjusted hydrology, natural hydrology, simulate, and then do statistical analysis to assess reliabilities of meeting water demands, frequencies for flow frequencies, storage frequencies, and other frequency relationships. And so we're talking about, on one side, natural hydrology, naturalized flows, other aspects of natural hydrology, and then on the other side, water resources development, building dams and conveyance facilities, allocation, all of that's listed here, and has been very clearly pointed out already today. Texas, like many western states, is a prior appropriation water rights state, so the modeling system is based upon a priority system. Is actually listed first here, and you go down the list. And then from the simulation results, we can do volume reliability, period reliability, what percentage of the total demand can be supplied by each permit holder, express period reliabilities, and we mentioned, can you meet 75% of your demand at least 75% of the time? Maybe you meet 80% of your demand, yes, and so forth. And so water management is about variability. And this is statewide mean precipitation, monthly precipitation in inches, 1940 through 2015 for the whole state. Of course, if you go to a particular gauge or region, there's even more variability. You're looking at a lot of rainfall variability. I'm not saying too much as far as long-term trends, but a lot of continual variability. That's annual rainfall, statewide means. The 1950s droughts evident. It's evident from this plot that 2011 was the driest year, 2015 is the wettest year of that period statewide. But 1950s is variability, quite a bit of variability. This is observed stream flow at the Waco gauge. Just south of the city of Waco, there's a gauging station. We're looking at mean daily flows from October 1898 through March 2018. And you see the non-stationarity is quite evident. And what you're seeing, you can look at this plot and tell when the U.S. Army Corps of Engineers built Lake Whitney and Waco and Aquila. And if you recognize that the non-damaging flows are 25,000 CFS, you can see those dams are doing a good job of taking the peaks off the flows. And so we call that non-stationarity, and this is a little exaggerated because this gauging station is relatively close to Lake Whitney and Waco. As you go further downstream, you don't see that as much. These are the annual observed flows, and time step makes a difference. Monthly flows have less variability than daily flows for obvious reasons. The WAM adjusts the gauged observed flows to have naturalized flows. So these are naturalized flows, and they should be stationary. If the people that adjusted them did a good job, meaning no long-term trend. But again, you're seeing tremendous variability, tremendous flow variability. Floods and droughts. You're seeing all the water we need. There's plenty of water there. It's just it all comes during flood events, and then we have long periods of dry event. What that slide says is you got to have reservoir storage. And as Bill and others have pointed out, we do have the reservoir storage to take the tremendous variation out of the flows to have a reliable supply. These are regulated flows from the model. The previous slide would be the flows that you would have if we didn't have dams and people and water use. These are the flows that we have based upon the premise that everyone that holds a permit uses all the water they're legally entitled to use. That's what the flows at that gauge would look like. Now in the WAM, there's large numbers of sites that these flow. And then unappropriated flows are less than regulated flows because some of the regulated flows have been committed to maintain in-stream flow requirements and so forth. And again, lots of water, but it's during flood events, and then we've got long periods of dry event. To me, drought, a good drought index is reservoir storage content. So this is the entire Brazos River Basin. We're looking at the end-of-month storage in 678 reservoirs, all the reservoirs in the Brazos WAM from 1940 through 2015, and we've added them together. Obviously, in preparing permit applications, planning studies, you just look at the reservoir you're interested in, one or several reservoirs. This is all of them added together. And what becomes evident is the 1950s drought. Should be able to clearly show the 1950s drought, then we all realize that probably, well, all of us at the table have been around longer, but a lot of people have not, were born after 1957. And so the point is the water management community has not experienced a drought equivalent. Now, the more recent drought, the drawdowns are quite significant, but not as bad as the 1950s drought, and this is true of many of the basins, most of the basins in Texas. So So this is what we know. We know that we're going to have water management is about uncertainty. We know that if the planet lasts long enough, we're going to have a drought worse than the 1950s drought. This is what we don't know. Is it going to start this summer, or is it going to start 120 years from now? We don't know when it's going to happen. And so we're, again, the focus on work here at A&M for the TCEQ is now on the daily modeling system motivated by the Senate Bill 3 requirement. Here's a list of continuing issues, and I'll make one comment. You can read these issues, and I'll make one comment. I'll tell my students there's two worlds. There's the world of reality, water management, water, dams, policies, and then there's the world of the computer model, which is an approximation of this world. And sometimes it helps to be on that borderline between sanity and insanity, be a good computer modeler. But this list of issues I made from the perspective of improving, expanding the WRAPMAM system, what do we need to deal with, but it's also a list of issues that in water management, what do we need to deal with in the next 20 years? We already, and you can read down the list. I think everything on this list has been talked about today already. And, but at any rate, concluding remarks, I'll conclude by saying the WAM system is routinely applied and has been for about 15 years by the TCEQ in the permitting process, the Water Development Board and 16 regional planning groups in the SB1 Regional Statewide Planning process. The range of applications has continued to expand. A driving expansion now is the Senate Bill 3 environmental flow requirements that's necessitating significant expansions of the modeling system. And then there's an array of institutional, hydrologic, constructed infrastructure. All these considerations are fundamental to water availability modeling, and I'll stop right there.